Hello friends, continuing with the chapter of current electricity. Today we take up sixth part of the topic measurement of EMF. This part is comparison of EMFs of two primary cells. So how we carry out comparison of EMFs of two primary cells? So let us try to learn. First, we try to understand how is the circuit diagram. Now look at the circuit diagram. AB is potentiometer wire. E auxiliary is the EMF of the auxiliary battery used for maintaining steady current through potentiometer wire of uniform area of cross section. MA is milliampere meter to record steady current. S is on off switch. Circuit diagram continued. C1 and C2 are two primary cells whose EMFs are to be compared. G is a galvanometer for detecting null point and is connected to cells through two-way keys K1 and K2. RS is the safety resistance for the safety of galvanometer connected through key K- and is generally of 1000 ohm. The other end of galvanometer is connected to sliding contact called as jockey. First position is J1, the other position is J2. So this is called jockey. It may assume any position on the wire AB. So we call it as jockey. Now precautions to be taken while comparing EMFs of two primary cells. First, ensure that EMF of auxiliary battery is more than the EMF of the primary cells. That is, E auxiliary is more than E1 as well as E2. 2. All the positive terminals of primary cells and auxiliary battery be connected to one point A. 3. Keys must be closed only when observations are to be taken. Otherwise, potentiometer wire will become hot, resulting into change in the resistance of potentiometer wire. 4. Safety resistance of 1000 ohm must be used in series with galvanometer for its safety and must be taken out while reaching near null point by closing key K'. 5th, rheostat must be of low value of nearly 20 ohm so that slight variations cause small change in current flow. 6th, clean all wires and joints before making connections and all connections be tight. 7th, press jockey gently on potentiometer wire so that its area of cross section does not change. So these are the precautions you have to take while carrying out comparison of EMFs of two primary cells. Now procedure. First point, testing the circuit. Before we proceed for measurement of EMFs of primary cells C1 and C2, we will first test the circuit whether it is correctly arranged or not. So how we proceed? First point, switch S is closed and steady current is maintained through potentiometer wire by fixing the position of rheostat and is recorded from milliampere meter. Key K1 is closed and K' remains open. Cell C1 is connected in the circuit. sliding contact jockey is brought near end A of the potentiometer wire and direction of deflection in galvanometer is recorded. This is the direction of deflection in galvanometer. Here it is towards left hand side. So this shows the direction of deflection of galvanometer. So let it be as shown, that is, it is towards left hand side. 3. Now sliding contact jockey is brought near end B of the potentiometer wire and direction of deflection in galvanometer is recorded. It must be opposite to the deflection at end A and should be as shown, that is towards right hand side. If it is not opposite but in same direction as shown, then there may be two defects in the circuit. Now what are those two defects? Let us see in the next slide. Now two defects. What are those two defects? Let us see. First defect may be either E auxiliary is less than E1, or second defect could be negative of primary cell C1 is connected at end A with positive of auxiliary battery. I repeat, either E auxiliary is less than E1 or negative of primary cell C1 is connected at end A with positive of auxiliary battery. Now how to identify which defect exists? How we will come to know which defect exists? Now if deflection at end B is less than at end A, here you can see deflection at end B is less than the deflection, magnitude of deflection at end A, then defect 1 exists, that is E auxiliary is less than E1 exists. And if deflection at end B is more than at end A as shown here, then defect 2 exists, that is negative of primary cell C1 is connected at end A with positive of auxiliary battery. That is, negative of primary cell C1 is connected at end A with positive of auxiliary battery. Okay, thus we can decide about which kind of defect exists in the circuit, and we can correct the connections, and then we can proceed ahead for measuring EMF of the cell. Now confirmation of correctness of circuit. Correct the circuit and confirm for opposite deflection at both ends when jockey is brought near them. Here you can look here, the deflection is on left hand side at end A, and at B deflection is towards right hand side. So this must be the situation while testing the circuit. Then only we can proceed for measuring EMF for purpose of comparison. 3. Adopt the same procedure for cell C2 also. Now after testing, second step is measuring EMFs of the cells. So first cell C1 in circuit. Now close key K1 here and move sliding contact gently on potentiometer wire and obtain null point. At this point, close key K dash and again obtain null point. Let it be at J1. Record length AJ1. Let it be L1. L1 here. Then E1 is equal to KL1. Let us mark it as equation 1. Now cell C2 in circuit. How cell C2 comes in circuit? Let us see. Now open key K1 and K dash. Close key K2. Move sliding contact gently on potentiometer wire and obtain null point. So this is sliding contact here. At this point, close key K dash and again obtain null point. Let it be at J2 here. Record length AJ2. Let it be L2. Then E2 is equal to KL2. Let us mark it as equation 2. Now 3. Comparison of EMFs. Now dividing equation 1 by 2, we get E1 by E2 is equal to KL1 by KL2. KK cancels and we are left with L1 by L2. So therefore E1 by E2 is equal to L1 by L2. Thus we compare EMFs of two primary cells using potentiometer. Now fourth, conclusion. Thus EMFs of two primary cells can be compared using potentiometer. Also, if EMF of one cell is known, the EMF of the other cell can be determined. This is another method for determining EMF of a primary cell. That is, we take one primary cell whose EMF is known, and by comparing EMFs, we can obtain the EMF for the other cell. We can determine the EMF of the other cells. Now assignment 3.7, question number 17. If the galvanometer deflection at the end B of potentiometer is number 1 more, number 2 is less than that at end A, which of the two faults listed above would be there in the circuit? Give reasons in support of your answers. Here listed above means the two defects we have already mentioned in the topic. Okay. Question number 18. Circuit diagram shows the use of potentiometer to measure a small EMF produced by a thermocouple connected between X and Y. Now you can see where is X and Y. Here we have X and Y. There is a thermocouple between X and Y. This is hot terminal. This is cold terminal. Okay. The cell C of EMF 2 volt has negligible internal resistance. The potentiometer wire PQ is 1 meter long and has a resistance of 5 ohm. The balance point is found to be at 400 nanometer from P. Calculate the value of EMF V generated by the thermocouple. Okay, so you are to calculate the value of EMF V generated by the thermocouple. So here you have the answer for the EMF generated between X and Y, that is across the thermocouple. Now thank you so much. Next time we will take up part 7 of this topic. Till then, goodbye and good luck to you.